Now, what we're doing today is dealing more with transformations. We talked about them yesterday and the day before. The last 2 days we've been talking about transformations. What we're going to be talking about today is applying those transformations. We're going to be given a function and we're going to move it up, down, left, right, vertical shrink, vertical stretch, horizontal stretch and shrink. We're going to apply these properties to the function. We're actually going to apply these movements, these transformations. So if we look at the first one, well, I already gave you all that, so you're not having to write all that out, which is kind of nice in its own way. Now, the first two we're going to look at, and the main two we're going to look at today, are horizontal translations and vertical translations. As we've talked already, horizontal is a movement left or right. Vertical is going to be a movement up or down. Now, the main thing with horizontal translation is this part here, f of x minus h. This part is key because we're going to use this equation to apply the horizontal translation, the movement left or right. So I would highlight it or circle it or do something to kind of key in on that there. F of x minus h. And that h value is going to be the amount that we move it left or right. And we will plug it in. If it tells us to move it right 3, we'll plug h in as positive 3 because right is positive. If it's to the left, we'll plug it in as negative 3. And we'll see how the sign thing works out, especially considering what we had yesterday. Vertical translation is how far the graph moves up or down. And the value of k, especially for our f of x plus k, will help us be able to apply that movement to our function. Questions on this so far? All right. Now, having it in words is one thing, but actually seeing it in a problem and actually applying it is going to make a little more sense. So the first thing we're going to do is look at this one here, and we're going to use this here, f of x equals 2x plus 1. That's the function we're going to be applying these transformations to. And it wants us to write a function g, whose graph is a translation 3 units down of the graph of x. Well, this here is vertical translation because up and down is vertical. And we're wanting to move it how far? 3 units down. So every point on the graph, we want to move it vertically 3 units down. Now, they give us a name for our new function, g. So we'll call it g of x. Now, g of x, h of x, q of x, this is just a way to name the function. It's not going to be crucial. It's more just up to us on how we want to name it. So here we're picking g of x is our new function. This is equal to, since we're talking about vertical translations, we're going to start off with the vertical translations general form, which is f of x plus k. Now, there is no stipulation or requirement that it has to be f of x plus k, because it could be g of x plus k, h of x. It's just whatever function we're applying this to. And normally we stick with f of x as just the general starting point. But it could be any letter. It's more, we're applying this vertical translation, this plus k, to f of x. Now, we could have added to g of x or h of x. It's just, this is what it's going to. Now, our value of k is our movement. So what is the value of k? Because it is 3, yes? Okay, so k is equal to 3. But which direction are we moving? Down, so it will be negative 3. So k, if it's up 3, it would be positive 3. If it's down 3, it is negative 3. And as we'll see here in a minute with h, left and right, if we moved left 3, h would be negative 3. If we moved right 3, it would be positive 3. Now the change of signs will come in, but the actual value of h, we don't have to do anything. We just read it as it is. So, questions on this so far? Okay. So our next step is to plug in our value. So we know what k is. K in our case is negative 3. So we're going to replace k with its value. K is our movement, and our movement for this one's negative 3, down 3. So we replace k with negative 3. Now, could we have replaced f of x as well? Well, yes, but we'll do that one step at a time. Now, we didn't necessarily need the parentheses around this because plus negative 3, we couldn't have written it as just minus 3, because plusing and negative, minusing it are the same thing. And we'll do that here in a second. Now, we need to apply this to the function f of x. Yes? Well, what is our function f of x? F of x is what? It is 2x plus 1. That is the function. It is our naming for it. And we're going to replace it. We're going to plug x into f of x, which is really just going to tell us that this here is 2x plus 1. And then we still have our plus negative 3, or we can just say minus 3. Questions on this here? Because we're almost done. We just need to drop the parentheses around our 2x plus 1 and then combine like terms. So we can drop the parentheses, and we do this because the number in front of the parentheses is just 1. There's no number or sign that we have to distribute through, so it just stays 2x plus 1. And lastly, what are our like terms? 1 and negative 3. What's 1 minus 3? Negative 2. So g of x for us, our new function is 2x minus 2. Questions on this here? So that's our new function, our function that where we took f of x and moved everything 3 units down. So we feel comfortable with going up and down. Yes? All right. We do have more examples of vertical translations, but before that, we're going to look at a horizontal. We're going to write a function h, whose graph is a translation 2 units to the left of the graph of f. So this time we're naming the function h of x. Is equal to, well, I'm rewriting f of x just because my version of f of x is up off the screen. Y'all's is still right there. So if you want to rewrite it, that's fine. I'm rewriting it so I'm not having to scroll up and down, up and down, up and down so that we can see it again. Okay. So this time we're talking about a horizontal left-right movement. Our general form for horizontal is f of x minus h. So here we can say h of x is equal to f of x minus h. And we'll use this here, this x minus h, to apply this horizontal translation, this movement left or right. Now, what is our value of h? So we have 2 units to the left, yes? So would the 2 that we're moving it to the left by be positive or negative? Negative, because the left is a negative movement, yes? But probably at least one of y'all thinking, well, we said it's the opposite, right? Because all that we talked about yesterday is always the opposite. Left and right's the opposite. And yes, when we're looking at it and identifying the movement, it is indeed the opposite. When we're applying it, h's value, if it's going to the left, would be negative. Now let's see what happens when we plug this in. So our h of x is equal to f of x minus our h. So it'd be f of, so f parentheses x minus negative 2. Do we ever leave anything as minus and negative? No. How would we rewrite x minus negative 2? Yep. We get x plus 2. Negative, negative made it positive. That's why, especially when we're identifying left-right movement, we have that kind of flip because of this negative, negative. Questions on this here? Okay. We ready for the next step? All right. Now, the original function for f that they gave us is they told us f of x is equal to 2 times x plus 1. Yes? For our function f, now do we still have f of x? Do we still have x inside the parentheses? Well, no, right? Because what is it now? It is x plus 2. So what I've done from this function, my marker over here, this f of x is I've changed this x to what? 2. I changed it from x to x plus 2, yes? Which means every x in this function now has to change from x to x plus 2. Everything else is going to stay the same. So the 2 in front of it will still be there. The plus 1 is still going to be there. But the x is going to become x plus 2. We're just changing the x to x plus 2. Anything that's being multiplied by the x stays. Anything that we have applied to the x is still going to stay. So I wouldn't write this in, but if we said that the function was, say, 2x squared plus 1, when we plug in the x plus 2, it would be 2 times x plus 2 squared. That power still stays there. We're just replacing that x. Questions on this here? And that's the key thing with this, is that it's changing that input. So we're replacing the x with x plus 2. We're normally, and we've done, just replacing it with a number, f of 2. Replace every x with 2. We're used to that. This is a little different because we're having to replace an entire expression, not just a single term. Now our next step and last few steps is just to simplify. We need to simplify this down where we can. So the first thing we need to do is distribute the 2. 2 times x is 2x. 2 times 2 is plus 4. And then we still have the plus 1. Are there any like terms? 4 and 1. 4 plus 1 is 5. That's it. Questions on this here? Now, this can get tricky if we try to do a lot of stuff at once or try to do it all at once. But if we take this step by step, one step at a time, each of the steps is not that bad. And again, as I said at the beginning of the year, that's the thing with Algebra 2. It's not so much that it's difficult all on its own, but when we try to do too many things at once, it makes it harder than it needs to be. Let's just take it one piece at a time, one step at a time, and we'll get to where we need to be. Now, most of these, the equation of a line is what we'll be dealing with. We'll deal some with absolute value. For this year, 1.3, we will not touch quadratics. That's going to be next chapter. Don't know why they do it that way, but they do. And I kind of like it that way, so we're not trying to deal with 3 different functions applying this here. We just look at 2, and it makes next chapter better because we'll only look at 1, quadratics, with transformations at least. F of x equals 4x minus 9. We want to write a function g whose graph is a translation 5 units up of the graph of f. So our new function's name is going to be g of x. We stick with x because x is our input. G of x is then defined as our output. Now again, here we're going up and down, so that is our vertical translation. In the general form of the vertical translation is f of x plus k. Now, as I said before, we could have it different from f of x. F of x is just the function we're applying it to. So if we wanted to apply it to g of x, we would just say g of x plus k. It's just taking a spot. Now, we need our value of k. How far we're moving it up or down. So we're moving it up 5, so k is 5. Specifically, it is positive 5. Because up 5 would be positive 5. We have plus 5. Now we can put it in parentheses if we want. Or we can leave it like this here. Either way works. Because if I put it in parentheses, we have plus parentheses 5, close parentheses. We drop it, we have plus 5. Doesn't make a difference. Questions on plugging that in? We're ready to plug the function in. So our function for this here is 4x minus 9. So that's our f of x. So we're going to replace f of x with its function, or technically we're plugging x into f of x. So I'm taking all the x's in f of x and replacing them with an x. Does that actually do anything? No. Well, next thing we need to do is drop the parentheses. Since there's not a number in front of the 4x minus 9, we're not going to distribute anything through it. Sign's not going to change. So it'll stay 4x minus 9 plus 5. And last but not least, we need to combine like terms. And our negative 9 plus 5 is what? Negative 4. And that's it. Questions on this so far? We feel good with everything so far. Okay. Let's move on to the next problem. Write a function h whose graph is a translation of 1 unit to the right of f. So our new function's name is h of x. Now the general form for this here is the function we're applying it to and having x minus h. So here we're applying it to f of x minus h. And h is the value that we're moving to the left or to the right. So our h value for this here is 1. And since it's to the right, it will be positive 1. Now for this one here, we're going to replace h with its value. So replacing h with 1, which will give us x minus 1. Now we don't have to have parentheses because we don't have a negative negative. And really, that's it for that step. It's just going to be f of x minus 1. Questions? Now again, we don't have f of x anymore. We have f of x minus 1. So that means every x in f of x has to be replaced with x minus 1. Now we'll still have the 4. Because 4 times x, well, not anymore. It's 4 times x minus 1 minus 9. Now sorry, I'm trying to think backward until the 4th hour, but questions on how we got to this here? Now the next thing and last thing we need to do is just to simplify. So what we're going to do is to distribute the 4. Right. Okay, yeah, it is minus 9. Our 4 times x is 4x. 4 times negative 1 is negative 4 minus 9. So we still have the 4x, but our negative 4 minus 9 is negative 13. So our new h of x function is 4x minus 13. Questions on any of these steps or anything we've done so far? Feel good for the most part? Nothing too over the top yet? Let's look at this one here. F of x equals 3x. And we want to move it up 5. We want to translate it 5 units up. Now, did they tell us what the name of the new function is? No, they didn't tell us what to name it. They just told us it's what the translation is. Well, we can call it whatever we want. What letter do y'all want to use? O of x is equal to So again, the generic version of this here for vertical translation is f of x plus k. Now our k value, the amount that we're moving up or down, is going to be what? 5. And since it is going up, the value of 5 is positive. So our k value is positive 5. Now at this point, we could plug it in one step at a time as we've been doing, or we can plug both in, because our f of x is what? 3x. Our value of k is positive 5. Because there's nothing that said that we had to do it one at a time. But if that does help doing it one at a time, plugging the k in first, and then writing out just f of x plus 5, then plugging in the 3x for f of x, you can. Don't have to, but you can. If that helps, do that there. Now again, at this point, there's nothing in front of the parentheses for f of x, so we can drop them, giving us 3x plus 5. Are there any like terms? So that's it. Questions on this here? Feel good with this so far? Let's look at the next one. F of x equals the absolute value of x minus 3. Translation, 4 units to the right. So we want to move this function 4 units to the right. Well, Ray, give me a letter for our function notation. S. So we can say S of x equals f of x minus h, because our f of x minus h is our general form of our left or right movement. And h is our movement to the left or right. So what is our value of h for this here? 4. Would it be positive or negative? Positive, because we're going to the right. Once we plug it in to the function notation, it's going to look negative, but that's just part of the function notation. So the next thing we can do is plug in our 4 in for h, giving us x minus 4. Now our original function, f of x equals x minus 3. But we don't have f of x anymore. We have f of x minus 4, which means every x in f of x's function, the absolute value of x, has to be changed to x minus 4. So we'll still have the absolute value. Our x, well, since it's the only thing in there, is going to be replaced with x minus 4 minus 3. Questions on this so far? Now we don't have anything in front of the parentheses inside the absolute value bars, so we can drop the parentheses, telling us that we have the absolute value of x minus 4 minus 3. Do we have any like terms? We do. The 4 and -3 are like terms, yes? But unfortunately, there is something between them, yes? The absolute value bar. Even though the -4 and -3 are like terms, that absolute value bar prevents them from combining. We can't combine them because that is that would be an operation that is blocking them from being able to combine. We'd have to actually take the absolute value of that before we could subtract the 3. So we can't move anything out of it, which is just telling us that s of x is the absolute value of x minus 4 minus 3. And we'll stop there for today.